Hello and welcome to Woven Chemistry. I'm Jean Weaver, and in this video we're going to be looking at limiting reactants. This is part 3 of a 4-part series. If you haven't watched part 1 and 2, I really recommend that you go back and watch those first. They're a little bit simpler, and some of the more fundamental concepts I go over there, but I'm going to just skim over them in this video. So in this video, we're going to look at a new reaction. We'll be using sulfuric acid instead of hydrochloric acid. And this will be a little more interesting because this is a strong diprotic acid and it reacts in a 2-to-1 ratio with sodium hydroxide. All right, so let's get started. Here's our reaction, and what we're going to do is we're going to combine 100 milliliters of sulfuric acid, 1 molar, with 100 milliliters of sodium hydroxide. These react in a 1-to-2 ratio, and they will give us 2 parts water and 1 part sodium sulfate. So our first task is going to be to depict this reaction at the microscopic level. Okay, and so that we can all have answers that are similar and easy to compare, let's all put 2 sulfuric acids in our picture. Now the sulfuric acid, because it's diprotic and because it's a strong acid, makes things a little bit more complicated. If you're in a high school level class, don't worry about this at all. Just pause the video right now, sketch out your answers, and then rejoin us when you're done. If you're in a college level class, let me explain what happens here with the sulfuric acid. So, as you probably know, sulfuric acid is a strong acid, and that means that it completely dissociates to the hydrogen ion and the bisulfate ion. What makes things complicated, however, is that bisulfate is also an acid, but it's a weak acid. And since it's a weak acid, that means that it only partially dissociates and creates an equilibrium. Now, when we say partially dissociates, that really means just barely dissociates. So when we draw our beaker and we consider what's in a flask of sulfuric acid, well, there's definitely some hydrogen ion, there's some hydrogen sulfate, and there's some sulfate ion. But the problem is these are only the species that are present. They're not actually present in equal quantities as this picture might lead you to believe. All that we can say without looking up Ka values and doing calculations is that the hydrogen ion is in greatest abundance, and next we have the hydrogen sulfate, and the sulfate ion is a distant third. So since these species are not present in equal molar concentrations, this makes drawing these things at the microscope level a little bit trickier. Now the good news is that when neutralized, sulfuric acid behaves as if there were 2 separate hydrogen ions and 1 separate sulfate. Now, again, this is not actually what's in solution, but it will behave this way. And so it will be perfectly fine for this exercise to draw our sulfuric acid like this. Now, if you want to learn more about how this actually turns out and what happens with the equilibrium, I encourage you to come back and watch one more of my videos, an addendum on the limiting reactants. Okay, so college students, now's the time. Pause the video, sketch out your answers, and again, draw your sulfuric acid like this, and then join me when you're finished. Okay, so welcome back, everybody. So like I said, we want to have 2 sulfuric acids. So here's one, and here's the second one. Now, when drawing the sodium hydroxide, it's really important to keep in mind that the equation shows how the chemicals react. We need to draw what we have. So we need to focus on the 1 molar, 100 mils. So it's the same for both substances, so we need to have 2 sodium hydroxides as well. Okay, now thinking about what this reaction produces, we want to focus on the reaction, on the equation. And we see that we make some water. So the hydrogen ions, 2 hydrogen ions, will combine with 2 hydroxides to make 2 waters. We'll cross those out, and we can make some sodium sulfate, and actually just 1 of those. All right, and so we'll cross those out, and we see that our base beaker is gone. Like everything has been used, which makes the base the limiting reactant. This leftover sulfuric acid makes this the excess reagent. And we can see that in the product beaker, because we're going to mix the acid and the base, there will be leftover acid. If we had universal indicator in here, the acid would appear red, The sodium hydroxide would appear blue, and the product, because of the leftover acid, would appear red. Okay, so there we have it. Here's our macroscopic, symbolic, and microscopic perspective of this reaction. Take a minute, pause the video, kind of study this and make sure that you understand it well. Moving on, our next task is going to be to sketch a graph of moles versus time of all four substances and show how they change. So I really recommend that you sketch out or calculate, make a little table here of the moles that you have of each of the four substances. So again, pause the video and come on back and join me when you're finished. Okay, so what do we have of each of these to start? Well, we've got 1 molar of each, and they're 100 mils. So using our equation, we see that we have 0.1 moles of each of the acid and of the base. Now, how much do we have of the product? Well, that's really easy. The reaction hasn't happened yet, so we have 0 moles of both of the products. How much are we going to use of the acid and of the base? Well, we see that they react in a 1:2 ratio, so the sodium hydroxide will be used faster. We have them in equal quantities, so we'll run out of the sodium hydroxide, and that will be all used up. And that's consistent with our pictures. The sodium hydroxide ran out first. Because we have the 1:2 reaction ratio, we're going to use half as much of the acid, so we'll only use 0.05 moles. And so when we're finished, we have 0.05 of the acid, and we have 0 moles of the base, again because it's the limiting reactant. Okay, so how much are we going to make of each of the products? Well, we have to focus on just the sodium hydroxide because we have 0.1 moles of that. The 0.1 moles of the acid doesn't matter because that's excess and that doesn't all get used. So we'll focus on the 0.1 moles of the base. And because of the reaction ratio and the 2:2 ratio or 1:1 between the base and the water, we're going to make 0.1 moles of the water. Now, because of the 2:1 ratio between the base and the sodium sulfate, we will make 0.05 moles of the sodium sulfate. So now when we're all done, we've got our final quantities of water and sodium sulfate, and we're all set to graph. Now, if you find that your numbers don't perfectly match mine, pause the video, correct them, and then adjust your graph. So with the graph, here are my numbers on the y-axis. I've set up where the reaction is going to stop, and there are my colors. So if we start with the acid, it's going to start at 0.1 at the top of the y-axis, and it's going to drop halfway down. The base, because it's the limiting reactant, will start at 0.1, but it's going to go all the way down. Notice that they both plateau at the same point where the reaction stops. And another thing to note here that's different than what we saw in the previous videos, the slopes of the acid and the base lines are different. The slope of the base line is twice that of the red acid line. That's because of the 1:2 reaction ratio. Okay, now let's work on the products. And we see that we're going to start with 0 moles of water and end up with 0.1. So that's going to go all the way to the top. And notice that the water goes up as much as the base declines. That's because of their 2:2 or 1:1 reaction ratio. And if we focus in on the sodium sulfate, that's only going to go up half as high. So it's going to go up to 0.05. Okay, now let's take a look at this graph and also look at our final microscopic depiction of the reaction. And in our picture, we see that we have 1 sodium sulfate and 2 waters, which is consistent with our green water line being twice as high as our yellow sodium sulfate line. And if we look a little further, we see in the picture, there's no base. Our blue line goes to 0. And there's 1 part sulfuric acid, and our sulfuric acid line goes down partially. All right, so there you have it. That takes us to the end. I hope that you learned a lot from this. The questions here I think were pretty challenging. They're fundamental questions, but they're challenging nonetheless. And I really encourage you to come back and watch part 4. We'll take the same reaction, but we're going to use different quantities of the acid and the base, which is going to make the math even a little more complicated. And we'll throw in enthalpy just to add another layer of challenge. So thanks a lot. Hope to see you again.